Hi there and welcome back to LP Maths. Today what we're going to be doing is National 4 substitution. So in maths, substitution works exactly the same like in sports. So let's say if you're a big rugby fan like me, you're watching say Scotland play and the front row need a rest because they're doing a lot of hard work. So let's just say number 1, who's a prop, needs a substitution. Then number 16 will come in place of number 1. But at the same time, you'll never have 16 and 1 on the pitch at the same time because they represent the same position. They represent the same thing. So that's the basic principle in sport. The same principle works in maths. The letter and the number are the same thing. Equals means they are the same thing. So the letter comes off and in place of the letter comes a number. And I guess the most important thing that you must do in substitution is clearly show where you're substituting. So I'm going to do a couple of examples to show you this. So we're going to let A equal 6 and B equal 3. So our first example is, let's do 3A. Okay, now first comment is there is an invisible sign between 3 and A. I say sign, I should probably say operation. That operation is multiply. So multiply is invisible here. So you might want to put it in underneath just so you're absolutely clear on what 3A represents. Now what we're going to do is A is coming off and 6 is coming on. Okay, so 3 times, right, A's gone off, what's going in its place is 6, so what you get is 18. Okay, question 2, we're going to go with A plus B. Okay, so again, we're doing A's coming off and 6 is coming on. B is coming off and 3 is coming on. 6 plus 3 is 9. Question 3. We're going to go with 4A minus 2B. Okay, now there's something you really need to be careful of here. There's multiple operations, okay? Multiple operations. What do I mean by that? Well, there's multiplying and there's subtraction. So you need to follow the rules of BidMaths. So what we're going to do is we're going to do our substitution first. So we know it's 4 times A. In place of A is going 6 minus 2 times in place of what B is, that is 3. We're following the rules of BidMaths, so we need to do the multiplication first. That is 24. 2 times 3 is 6. We're taking them away from each other, and what we get is a final answer of 18. Continuing on with example 4, I'm going to use famous equations and show you how it works in famous equations. So we're going to use S is equal to ut plus a half at squared. Okay, we're going to let u equal 5, t equal 2, and a be equal to 4. Okay, this is a formula for displacement and it's used in physics quite a lot, so this is what we're going to do. We're going to use it just now. Now you can see there are multiple operations going on here. You've got indices, you've got multiplications, you've got additions, so we need to be very careful when we do that. But the first thing I'm going to do is I'm going to put all the numbers in first. Now you need to be very careful with this. So u, what's u? U is 5. U, invisible sign is multiplying by t. T is 2 plus a half. Again, invisible signs are all here, so these are all multiplying. So it's a half times 4 times 2 squared. Okay, we are using BidMaths. So BidMaths says I have to do the indices first. That's your I. So that's 4, and everything else stays where it is. And then the next part is the multiplication. So we can do all the multiplications. So 5 times 2, we know that's 10. We have 10 times 4 times, we have a half times 4 times 4. 4 times 4 is 16. Half of 16 is 8. So what we're going to do is just add them together finally to finish off, and we get 18 as a final answer. Now, I'm not going to give you a unit measurement just because I haven't defined any units to begin with. One that we have probably already come across if we've already done that for numeracy, it is your DST. So if I have D is equal to question mark, S is equal to 20, and T is equal to 5. Again, I'm not putting units of measurement in here. I don't really think it's necessary. We're just trying to get the idea of substitution in. And you know that the formula is D is equal to ST. You now substitute in. You know that S is 20. You know the invisible sign between these is multiply, and T is 5. So D would be equal to 100. What we're going to do now, just to finish off, is we're going to find the volume of a football. We're keeping it nice and sports themed. So we have a formula for the volume of a sphere, and it is the formula that you can see here. It's 4 over 3 pi r cubed. Now, I'd be expecting you to use a calculator with this because obviously cubing a number is quite difficult, and pi is a constant which is 3.1415, and it goes on and on and on, and it is what we call irrational, which means it has an infinite amount of decimal places that we know of so far. So the only information I'm going to give you is the radius of the football is going to be 35 centimeters. So I am giving you a unit this time to be aware of, okay? So 4 over 3 is a constant which we can't change, so we keep 4 over 3 in. All of these terms, they have invisible signs between them, so they're multiplying each other. Pi, we're not going to put any numbers in because pi is a constant. We just put pi in and that represents the number perfectly. And then in place of r, we're putting 35 and we are cubing that. Okay, now what you want to do next is you want to put it into your calculator just to make sure that you're getting the absolute right answer. So what you do is 4 over 3 times pi times 35 cubed. And remember what cubed means. It means to multiply by itself 3 times. So that's in effect saying 35 times 35 times 35. But because we're putting this in a calculator, it's all good. The answer you get your calculator is 171,500 pi over 3. Now that is useless to us because we don't really know what that means. So you press your SD button on your calculator, and what you get is a decimal. And that decimal answer will be, oh, this is really big. This is a really big what we're talking about here. 179,594.38. And that seems to be an exact value, so that is wonderful. And the unit measurement for that is because we've got centimetres times centimetres times centimetres is centimetres cubed. And that is obviously the same for any volume that you might have. So this last example, that's a tricky one. It's technically a Nat 5 question, but I thought I'd just show you what it looks like. Because it's a calculator, it's relatively easy. I hope that has been useful for you. Please follow my maths channel, LP Maths, on YouTube, and share it amongst your friends if you thought this was useful. Thanks very much, and we'll see you later.